In this video, I will share an experiment to plot volt-ampere characteristic curves of a semiconductor diode. A semiconductor diode has two portions. One portion is made of p-type semiconductor and the other portion is made of n-type semiconductor. The interface of two portions is called p-n junction, and so a semiconductor diode is also known as p-n junction diode. P side of the diode is represented as a triangle and N side as a vertical line. A semiconductor diode is said to be forward biased if P side is connected to positive of battery. The diode is said to be reverse biased if P side is connected to negative of battery. This is the circuit diagram for plotting volt ampere characteristic curve for diode when it is forward biased. Sufficiently high current flows through the diode when it is forward biased, and this current is due to majority charge carriers. Volt ampere characteristic curve is not a straight line. This means a semiconductor diode does not obey Ohm's law. This is the circuit diagram for plotting volt ampere characteristic curve for diode when it is reverse biased. Very small amount of current flows through the diode when it is reverse biased, and this current is due to minority charge carriers. This current remains constant up to some voltage, and this constant value of current is called reverse saturation current. At a particular high voltage, the reverse current starts suddenly rising, and it happens due to breakdown of chemical bonds between material atoms. The reverse bias voltage at which the reverse current starts suddenly rising is called breakdown voltage of the diode, and it is denoted by capital V with subscript B. Let me introduce the apparatus. This is battery. This is PN junction diode, before which a series resistance RS has been connected. This is ammeter. This is voltmeter. Make connections according with this diagram. Positive of the battery is to be connected to P side of diode. N side of diode is connected to positive of ammeter. Negative of ammeter goes to negative of battery. Connect positive of voltmeter to positive of battery and negative of voltmeter to negative of battery. Switch on power supply. With the help of this knob, go on changing voltage value and record corresponding values of current. Now make connections when the diode is in reverse bias. In this case, negative of battery is to be connected to P side. N side of diode goes to negative of ammeter, positive of ammeter to positive of battery. Connect positive of voltmeter to positive of battery and negative of voltmeter to negative of battery. As done in previous case, change voltage and note corresponding values of current. Using the observed values of voltage and current for forward and reverse bias diode, plot characteristic curves of the diode. From the graph, note the values of reverse saturation current and breakdown voltage. Thank you.